Chemistry can be thought of as an inverted pyramid in terms of what we learn and how we apply it. And we're learning some very simple things so far: how to calculate atomic mass, molar mass, gram formula mass. And what it does is it opens up the door for us to begin looking at conversions between moles and mass. And this will eventually lead us to a broader topic called stoichiometry, which is down the road for us just a bit. But here again is that inverted pyramid where we learn something very simple that again allows us to engage more and more complex topics as we go. So let's take a look at a problem where we're going to convert between moles of a substance and mass of a substance. So consider the following problem. We have 24 grams of magnesium chloride and we want to change this to moles. Now when we get to stoichiometry, we'll find out that we cannot compare different substances by mass, but we can compare them in terms of the mole. In the laboratory, however, we don't have mole balances. We can't directly measure moles. So what we'll do is we'll measure the mass in grams and then convert to moles for the purpose of comparison, and then convert back to mass at the end so that we have a measurable quantity in terms of our lab problem. So we're going to take 24 grams of magnesium chloride to moles. And so the first thing we want to do to solve this is I always write a little bit of a map. And here I have my map. I have 24 grams of magnesium chloride going to moles of magnesium chloride. And if you've watched the unit conversions podcast, you know that this map tells me what my starting quantity is, and it tells me what my ending unit must be. And that's very important as we go to do this. I have to find the relationship between 1 mole of magnesium chloride and the mass in grams of magnesium chloride that would be equal to 1 mole, or 6.02 times 10 to the 23rd particles of magnesium chloride. So this is my equality. 1 mole of magnesium chloride will have a mass of 95.21 grams. Once I have my equality that 1 mole of magnesium chloride is equal to 95.21 grams, I'm going to set that equality as one side of a ratio. So I have 1 mole of magnesium chloride over 95.21 grams of magnesium chloride is equal to X moles of magnesium chloride over 24.0 grams of magnesium chloride. Now when I set up this ratio, I set it up with the unknown quantity that I'm trying to find on top in the ratio. And when we look at the next slide into how we solve this, you'll see why I did that. But here's a simple ratio that enables us to compare moles in grams of magnesium chloride. I have my equality, I have my ratio, and now all I have to do is solve for x. So I'm going to isolate x. Now in algebra they would teach you to cross multiply and divide here, and that's certainly a wonderful way to isolate x. My way is just to think of the equal sign as a bridge, and I want to take the quantity that's underneath x, the 24 grams of MgCl2, and have it cross that equal sign bridge. If that quantity is divided on the original side, when it crosses the equal sign bridge, it has to be multiplied. It's just a simple way of isolating x. And again, this is not a way that I'd recommend you tell your algebra teachers, but it's a simple way for me to get x without going through the process of cross multiplying and dividing. So again, I isolate x by taking 24 grams of magnesium chloride to the other side where it's multiplied. In algebra they would say, well, you could just multiply both sides by 24 grams of MgCl2 and accomplish the same. And you have to do the method that makes sense to you. So make sure that if you have an algebraic method of isolating a variable so that you can solve for it that is very comfortable for you, you stick with that. But I just wanted to give you my suggestion because it's pretty easy for me. So I have my 24 grams of magnesium chloride, and I multiply it times my conversion factor, which I've called an equality before, of 1 mole of MgCl2 over the molar mass of 95.21 grams of MgCl2. And when I do that, my grams cancel, and I'm left with moles. and it happens to be 0.252 moles of magnesium chloride. Notice here that there are 3 significant figures because of the 24.0 grams of magnesium chloride that I started with. And again, when I look at the conversion factor, or the equality as we called it in previous slides, I put the unit that I'm going to on top, which is the mole, and I put the unit that I'm coming from on the bottom, so that that unit will cancel out and leave me with the desired unit as I go. So that's how you do that. Well, let's do some sample conversion problems together. First one we're going to do is we're going to take 1.75 moles of benzene, which is C6H6, to grams of benzene. The second one will be 3.14 times 10 to the 24th formula units of calcium sulfide, 2 moles of calcium sulfide, and finally 20 grams of nitrogen dioxide to molecules of nitrogen dioxide. So the first one, we're going to take 1.75 moles of C6H6, 2 grams of C6H6. I have to have an equality there between moles and grams, so I know that 1 mole of C6H6 is equal to 78 grams of C6H6. So I set my ratio. I have 78 grams of C6H6, or benzene, over 1 mole of benzene is equal to X grams of benzene over 1.75 moles of benzene. I then isolate my X grams of benzene and take my 1.75 moles of benzene times 78 grams divided by 1 mole of benzene, and that gives me 136 grams of benzene. My next problem, I want to convert 3.14 times 10 to the 24th formula units of calcium sulfide to moles of calcium sulfide, and I know that in 1 mole of calcium sulfide there are 6.02 times 10 to the 23rd formula units. Now, I set up my ratio. I have my 1 mole of calcium sulfide over Avogadro's number, or 6.02 times 10 to the 23rd formula units of calcium sulfide, equal to X moles of calcium sulfide over 3.14 times 10 to the 24th formula units of calcium sulfide. I isolate my X by moving 3.14 times 10 to the 24th formula units of calcium sulfide to the other side, and multiply that by the conversion factor. And so I take my 3.14 times 10 to the 24th formula units of calcium sulfide times 1 mole of calcium sulfide. I then divide that by 6.02 times 10 to the 23rd formula units of calcium sulfide. The formula units cancel, and I'm left with moles of calcium sulfide, and it's 5.22 moles of calcium sulfide as my final answer. My final sample problem has to do with taking 20 grams of nitrogen dioxide to molecules of nitrogen dioxide. This sometimes is the hardest thing to grasp. It's easy for us to look at, okay, 1 mole is equal to molar mass, and 1 mole is equal to 6.02 times 10 to the 23rd. But oftentimes it's a little harder for us to make the connection that if 1 mole of nitrogen dioxide is 46 grams of nitrogen dioxide, and 1 mole of nitrogen dioxide is 6.02 times 10 to the 23rd nitrogen dioxide molecules, then 46 grams of nitrogen dioxide would be equal to 6.02 times 10 to the 23rd nitrogen dioxide molecules. But it is, and it's a connection that we need to make. So look at this one really carefully. I'm going to set up my ratio. So since I'm going to molecules of NO2, I'm going to put that on top in my ratio. So I have 6.02 times 10 to the 23rd molecules of NO2 in 46 grams is equal to X molecules of NO2 in 20 grams. So I have my equality that 46 grams of nitrogen dioxide is equal to 6.02 times 10 to the 23rd nitrogen dioxide molecules. I have my ratio, and then I can isolate X by moving 20 grams of NO2 to the other side through whichever mathematical method makes most sense to you. So I take my 20 grams of nitrogen dioxide times my equality, which is the conversion factor, 6.02 times 10 to the 23rd molecules of nitrogen dioxide on top, over 46 grams of nitrogen dioxide. Grams cancel, and I'm left with 2.62 times 10 to the 23rd molecules of nitrogen dioxide. Time for your turn. I have 4 problems here that I'd like you to do, and the best way to go after this is to write down the problems, pause the podcast and write down the problems, then work them, and when you're done working them, resume the podcast and I'll show you the answers and we'll see how you do. So go ahead and pause the podcast now, write the problems down, and I'll see you back in a couple minutes. In order to solve these problems, you need to find the molar masses of both the iron 2-phosphate and C3H8, which is also known as propane. So here's the molar mass of iron 2-phosphate, and you can see there are 3 irons, so 3 times 55.847 grams would equal 167.54 grams of iron. 2 phosphoruses, how's that for plural? 2 phosphorus atoms, or moles of atoms, would be 2 times 31 grams, which would give you 62 grams of phosphorus. And 8 oxygens would be 8 times 16 grams per mole of oxygen, which would be 128 grams. We total that to 357.54 grams per mole. The molar mass of propane, C3H8, much easier to find. We have 3 carbons. 3 times 12 grams per mole of carbon gives us 36 grams of carbon in 1 mole of this compound. 8 moles of hydrogen for every mole of C3H8 gives us 8 times 1 gram of hydrogen per mole, so 8 grams. Add those together and we get 44 grams per mole as the molar mass of propane. Once we have the molar masses, we can go ahead and then solve the problem. We find our equality that 1 mole of iron 2-phosphate is equal to 357.54 grams of iron 2-phosphate. Now I set up a ratio here which I encourage my students to do, but many of you will find that you can actually skip this step and just take your starting amount of 60 grams of iron 2-phosphate, multiply it times your equality set as a conversion factor with the unit that you're going to on top, which is 1 mole of iron 2-phosphate over the molar mass, which is 357.54 grams of iron 2-phosphate. And the grams will cancel. You're left with moles, and in this case it would be 0.168 moles of iron 2-phosphate. Use the ratio if it helps you. If you can skip the ratio part and go straight to the multiplying the starting quantity by the conversion factor, you're more than welcome to do that. So you do what's best for you, what enables you to see and solve the problem best. In this one I want to change from 60 grams of iron 2-phosphate to the number of formula units of iron 2-phosphate. So I know that there are 357.54 grams of iron 2-phosphate in 1 mole, and this would be equivalent to saying that 6.02 times 10 to the 23rd formula units of iron 2-phosphate would have a mass of 357.54 grams. So again, I've set up a ratio here. It is not necessary for you to do the ratio if you can see taking your starting quantity, 60 grams of iron 2-phosphate, times your equality set up as a conversion factor with the unit you're going to on top, 6.02 times 10 to the 23rd formula units of iron 2-phosphate, over the molar mass, 357.54 grams of iron 2-phosphate. The grams of iron 2-phosphate will cancel, and you're left with 1.01 times 10 to the 23rd formula units of iron 2-phosphate. Third problem involved converting or finding out how many grams of propane, C3H8, are contained in 3.25 moles of propane. So first I need to find the equality between what 1 mole of propane and the number of grams of propane would be. So I know that the molar mass is 44 grams per mole. So again, I set up a ratio here. For those of you who find that helpful, please continue to do so. But I'm going to take my starting quantity, which is the quantity that I know I have, 3.25 moles of propane, multiply it times my equality set up as a conversion factor, 44 grams of propane over 1 mole of propane. The moles will cancel, and you're left with 143 grams of propane as your final answer. Notice that the number of significant figures is determined solely by the quantity that you start with. The molar mass and a conversion factor is known exactly, so it does not contribute to significant figures. Only the starting quantity does that. Final problem is where we are taking a number of molecules of propane, in this case 6.50 times 10 to the 24th molecules, and changing it to moles. Our equality is that we know there's 1 mole of propane, C3H8, in 6.02 times 10 to the 23rd molecules of C3H8. And to try and make this fit better on the slide, I'm abbreviating molecules as M-cules. So set up the ratio if that's helpful. So I have 1 mole of C3H8 over 6.02 times 10 to the 23rd molecules of C3H8 is equal to X moles over my starting quantity 6.50 times 10 to the 24th molecules of C3H8. I multiply my equality in the form of a conversion factor by my starting quantity 6.50 times 10 to the 24th molecules of C3H8 times 1 mole of C3H8 over Avogadro's number, or 6.02 times 10 to the 23rd molecules of C3H8. The number of molecules will cancel, and I'm left with moles, and in this case 10.8 moles of C3H8. How'd you do? This concludes the Ontario High School video podcast regarding moles and mole conversions. And if this is something that you're continuing to struggle with, please feel free to watch this again, and certainly go to your instructor or other students in the class who are not struggling with this and get help from them as well. I wish you well with this.